Today we'll learn what the spark plug does and how it works. We'll learn symptoms of a faulty spark plug, how often to change your spark plugs, and different types of spark plugs you can buy. Here's an engine cylinder head. Here's the spark plug. Its primary job is to create a spark and ignite the air and fuel mixture in the combustion chamber. Pretty much it's like making an artificial bolt of lightning. It's a controlled explosion which we call combustion. The spark plug's secondary job is to transfer heat away from the combustion chamber to the cooling system. So how does it work? Let's look inside. Here's the connector. This is where the ignition system supplies high voltage to the spark plug. The electrical energy is incredibly high. We're talking some 20,000 to 40,000 volts. The current flows down this central electrode. This piece is usually made of copper so that it can serve as a conductor. It's surrounded by insulation to ensure the current flows only through the central electrode and not leak outside. The current then passes through the resistor here. Why is this piece important? Well, when a spark is made, it generates electromagnetic pulses. The problem is, this noise interferes with other electronic equipment like your smartphone, radio, navigation system, and ECU. But the resistor suppresses the electromagnetic interference and prevents it from impacting your gadgets and devices. Next, the electric current passes through the insulator nose. And when it finally reaches the end tip of the center electrode here, it jumps the gap and then reaches the ground electrode here, which is grounded on the engine. This gap in between, where the electrons jump, is called the electrode gap. This gap is important because when the high voltage current jumps, it ionizes the gas in this space. The gas, in essence, becomes a conductor, and it carries the electrical current and enables it to jump across. This jump is called an arc. Its high temperature and high energy causes the air-fuel mixture within the chamber to ignite. Now let's look at the external parts of the spark plug. This is the screw thread. This is how the spark plug attaches to the engine. The distance from the lowest thread to the washer here is called the reach. This distance is important when you're changing your spark plug. You'll want to use the reach that's recommended by your car manufacturer. That's because if the reach is too long, it may cause the piston crown to collide with your spark plug's ground electrode. It'll also cause carbon deposits to build up on the thread. Here is the hex nut. You use this to tighten or loosen the plug into or from the engine. This here is a porcelain insulator. The porcelain material prevents any leaking volts from flowing down and reaching the ground electrode. Otherwise, you could get a short circuit if the electrons were able to flow and reach ground. This insulator has waves and ribs. It's a tactic to increase the surface area and distance, just to make it harder for the voltage to reach ground. Spark plugs age over time. Deposits eventually form when they interact with the air-fuel mixture. The metal parts erode and the electrode gap widens over time due to temperature, debris, and normal wear and tear. If the gap gets too far apart, this causes the spark plug to misfire, which then causes the piston to work improperly and leads to erratic and ineffective combustion. You'll be able to hear, feel, or just sense when your spark plugs are going bad. One sign is that you'll hear a rattling or knocking noise. Another sign is your car won't start or it'll struggle to start. It also idles poorly. Also, when a spark plug isn't performing at 100%, your car performance will be poor. You may notice that the car is sluggish and it gets less fuel economy than normal. You can also read a spark plug. If the insulator firing nose is a light tan, brown, or gray color, that's normal, and it means the plug is operating at optimal temperature. But if it's a darker color, like heavy black wet or dry deposits, this can indicate some problems. For example, accumulated deposits can be a result of oil leakage, fuel quality, and the engine's operating duration. If the nose is glazed or glossy, that's due to the deposits melting, and this is a sign that your spark plug is overheating. The general rule of thumb for most cars is to change your spark plugs every 30,000 miles. But of course, always refer to your car owner's manuals for specifics. Also, it's good to change all spark plugs at the same time. This ensures consistent performance. Changing spark plugs can be a DIY project. Generally, you'll see a spark plug in each cylinder. A common spark plug can cost anywhere between $2 to $20 depending on the type, material, and brand. There are two main types of spark plugs, hot and cold. This simply refers to the thermal characteristics of the spark plug. A hot spark plug heats up quickly. It has a long, thin insulator nose. We can usually find hot spark plugs in smaller engines, like in lawnmowers. A cold one is heat resistant. It has a short, wide insulator nose to help dissipate heat more quickly. We can find cold spark plugs in high-performance engines, which have high pressure and high temperatures within the combustion space. We can usually find the heat range written on the porcelain insulation part of the spark plug. Typically, you'll see a number between 1 to 10 or 11, depending on the maker. A spark plug for a lawnmower can have a low heat range of 2 to 5, whereas a racing car may need a cold spark plug with a high heat range of 10 or 11. A spark plug's lifespan depends on its type, material, and condition. The standard spark plug is made of copper. These plugs have the shortest lifespan. Typically, they last 20,000, maybe 30,000 miles. That's because its center electrode is made of nickel alloy, which is soft and not so durable. It also requires more voltage to generate a current. Copper plugs are better for older cars that were made before 1980. Platinum spark plugs can better withstand erosion that occurs from high voltage ignition. Also, the end tip of the center electrode is almost needlepoint, which improves the spark plug's performance. Many platinum spark plugs have a small platinum disc that's welded onto the receiving face of the side electrode, so that the spark jumps between two platinum surfaces. This reduces spark erosion and elongates the spark plug's life. Platinum spark plugs can last 60,000 up to 100,000 miles, depending on your car type and frequency of use. Then we have the Iridium spark plug. This is the most durable and lasts 25% longer than the platinum spark plug, up to 120,000 miles. The center electrode in these spark plugs are smaller. This means they use less voltage to generate electric current. Of course, this also means they're more expensive than the other types. We can find spark plugs in traditional gasoline engines, but diesel engines don't use spark plugs. They use a compressed ignition system where the fuel-air mix is compressed and ignites through pressure and heat alone. That's because diesel fuel is much more energy dense. The advantage with compressed ignition is that more air and less fuel enter the cylinder. That's why the diesel engine is more fuel efficient than the traditional gasoline engine. The compressed ignition system also allows it to generate more torque at low revs. But on the downside, they struggle in the high RPM department since diesel burns slower than gasoline. That's where the brilliance of the Mazda Skyactiv X comes in. Skyactiv is Mazda's first gasoline engine to offer the best of both worlds. It combines the fuel efficiency and high torque of a diesel engine with the gasoline engine's high RPM responsiveness. The result is an engine that pulls strongly throughout the full RPM range. It achieves this by using the spark-controlled compression ignition, or SPCCI. Basically, it compresses the fuel-air mixture at a higher compression ratio. This allows it to operate much leaner and efficient than a typical spark ignition engine. When the compressed mixture is about to detonate, a second injector sends additional fuel on the spark plug to ignite only a small, dense amount of the fuel-air mix in the cylinder. This instantly increases cylinder pressure and temperature so that the rest of the mixture can ignite under pressure like diesel. So what you get is faster and more complete burn of the mixture, and the result is up to 30% more torque, plus more power and better fuel efficiency. It's one of the latest innovations in the world of combustion engines. And there you have it. If you like this video, please give it a thumbs up and subscribe to my channel. Thanks for your support, and see you next time.